Alright, so now we're going to get beyond just finding the side lengths of a triangle. We're going to get into looking at the angle measurements. So remember for right triangles that we have the Pythagorean theorem. A squared plus b squared equals c squared. You have to be able to determine what your hypotenuse is of your three sides. So remember, C is always the hypotenuse, and it's always the longest side, and it's always across from the right angle. So that's always your hypotenuse, and it's very important that you're able to at least determine which one is the hypotenuse. So again, trigonometry is the study of a triangle. So now we're going to start looking at the relationships between our angles and our side lengths. So if we think about a graph of a line going through the origin at a certain angle or slope, we know that that angle that it forms with the x-axis forms our slope, our rise over run. Okay, so our slope is our rise over our run. What we can also know is that ratio for our slope is always the same if that angle or that slope is the same amount. So when the rise over the run, your slope is the same, the angle that you are at is also the same, and that's called our tangent. So the tangent is the slope ratio of a certain angle, and it ends up forming a right triangle, okay, because we have our rise over our run. And what always ends up happening is that instead of calling it our rise over our run, we're going to say that from our angle, it's our opposite side over our adjacent side. Okay, so tangent is the opposite over the adjacent. So we're going to solve for the tangent of each specific angle. So we're going to find the tangent of A and set up the ratio, the tangent of B, and then we're going to do both the tangent of C and the tangent of D. So if you want to set those up and then come back, you're setting up your ratio from our angle for the opposite over the adjacent. So pause the video and then come back. Alright, so we can see that the tangent of angle A is our opposite, 15, over our adjacent side, 5, which reduces to 3. For B, our opposite over our adjacent is 3 over 4, which we can reduce to the decimal if we want, to 0.75. And then for C, our opposite over our adjacent is 7.3 over 8.1. And remember, we don't want to leave decimals inside a fraction, so we go to 4 decimal places. So when we divide that, we get decimal 9012. For D, opposite is 8.1 and the adjacent is 7.3. So therefore, when we divide that, we get a decimal of 1.1096. So again, we go to 4 decimal places. So what we can then do is, if we know the angle measurement, we can set up our ratio and determine a missing side length. Right? So I want you to try and do that yourself and then come back and check the video. Okay, so setting up your ratio, we have our angle, we have our opposite side, and our adjacent side. So the tangent of 50 is equal to x over 4. Multiply by your denominator. So 4 times the tangent of 50 equals x. When you type that into your calculator, make sure that when you do the tangent of 50, you get this decimal, which does go on forever, but I went past 4 decimal places because it was a 5. Now, on your calculator, if you see what you type, you would type it as tan 50. If you don't see what you type, you would press 50 and then press the tangent button. But also make sure that your calculator is in degrees. So again, remember that we're going to go to 1 decimal place for side length, so we round this to 4.8. For example B, we have tangent of 60, opposite over adjacent. So now we have 15 over x. We're not simply just going to divide or multiply our 15 times tan 60 because x is in the denominator now. So we multiply by our denominator to get rid of our fraction, and now we can see to isolate x we have to divide by the tangent of 60. So 15 divided by the tangent of 60 gives us 8.66 and beyond, so we know that we have 8.7 as our length of x. Okay, so rounding, lengths go to 1 decimal place, angles go to no decimal, and trig functions go to 4 decimal places. Okay, but the key thing is that we won't necessarily have our opposite and adjacent all the time, and instead of having to solve for the third side length using Pythagorean theorem, we can use our other relationships, our sine, our cosine, and our tangent. So the primary trig ratios are sine, cosine, and tangent that we can use for right triangles. So a way that we can remember it is SOHCAHTOA. Okay, SOH stands for sine equals opposite over hypotenuse. Cosine is cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So SOHCAHTOA. All right, so find the three trig ratios of theta. Theta represents our missing angle. So if we have our theta, you want to think of, if I have my three side lengths, from theta, which one is the opposite, which one is the adjacent, and which one is the hypotenuse. Because remember, it depends on which angle you're looking from. The hypotenuse will always remain across from the right angle, but your opposite and your adjacent will switch depending on your acute angle. All right, so I want you to set up your three ratios for theta and then come back to the video. Okay, so from our theta, we can see that 12 is our opposite, 5 is our adjacent, and 13 is our hypotenuse. So our three primary trig ratios are that the sine of theta is 12 over 13, our cosine of theta is 5 over 13, and our tangent of theta is 12 over 5. And we reduce it to lowest terms, but because there's no decimals, we can leave it in fraction form. So what happens when we want to actually solve for our angle measurement? So when you want to find your missing angle measurement, you're going to use the inverse operations. So the inverse sine, the inverse cosine, and the inverse tangent. So that is the inverse operation. It undoes taking the sine ratio. So if we have that the sine of angle A is 0.5, we want to undo sine. Remember, sine is an operation, so we have to do the inverse sine of 0.5, which would end up giving an answer of 30 degrees. Same thing, if we have the cosine of B is 0.5, then the inverse cosine of 0.5 gives us 60. So you can see how, even though it was a 0.5, because we did different operations, the inverse sine or the inverse cosine, we got different answers, okay, because they do different things. The tangent of theta, if it's 5 over 2, the inverse tangent of 5 over 2 will give us a decimal that we can round to the nearest degree, being 68 degrees. So for example 3, I would like you to calculate all three missing angles. So we know C is 90 degrees. So then if we want to find angle A, we want to think, okay, well, what is 13? 13 is our adjacent side, and 18 is our hypotenuse. So for A, we have the adjacent and the hypotenuse, AH, so we're going to use cosine. For B, we have the opposite and the hypotenuse, so OH, we're going to use sine. So try and work out what the angle measurements are for each of them, and then come back. Okay, so we can see now that for A, the cosine of A is 13 over 18, so the inverse cosine of 13 over 18 will give us 44 degrees. And for B, we're looking at the opposite over the hypotenuse. So the sine of B is 13 over 18, so the inverse sine will give us 46 degrees, which makes sense because remember 44 plus 46 adds to 90, and then we already have a 90 degrees there. All right, so remember, calculators need to always be in degrees, and then what we can also look at is angle of elevation and angle of depression. So remember, they're always going from the horizontals. So when we look at this triangle, this 50 degrees is neither of them because the angle of elevation will be from a horizontal up. So when we look at B, this is an angle of depression because it's from the horizontal down. And when we look at C, 64 degrees is the angle of elevation because it's from a horizontal up. So what I'd like you to do is go ahead, solve for X in all three of these. Try and think of what sides you're using, so which trig function you'll use. Press pause and then come back when you're ready. Okay, so for triangle A, we have the opposite and the adjacent. So O and A tells us tangent, so tangent of 50 is equal to x over 4. Get rid of your fraction by multiplying by 4. So 4 times the tangent of 50 is equal to our side length to 1 decimal. We get 4.8. For B, we have the adjacent and the hypotenuse. So cosine of 15 is equal to x over 21. Multiply both sides by 21. So x is 21 times the cosine of 15, which gives us a side length of 20.3, which makes sense because remember it has to be smaller than our hypotenuse, so 20.3. And C, we're dealing with the opposite and the hypotenuse, so sine of 64 is equal to x over 14, multiplying by 14 to isolate x. 14 times the sine of 64 gives us 12.6, which again is smaller than our hypotenuse. Right? So the very last example that we're going to look at, example 5, if a wire 20 meters long is attached to an 18-meter tall tree, what angle does the wire form with the ground? So remember, are we looking for this angle up here or this angle down here? So what angle does the wire form with the ground? So you should be thinking of this angle. So we have our opposite and our hypotenuse. So we're going to be using the sine of our angle is equal to 18 over 20. So go ahead, solve for that angle and come back to the video when you're ready. So you should have gotten 64 degrees from taking the inverse sine of 18 over 20, making sure your calculator was in degrees. So you're going to go ahead and do some practice problems, and when it asks you to solve the triangle, that means you need to find all of the unknowns. So I do want you to do some practice problems just with tangent and sine and cosine. So on page 362, do 1 EOL and 4 EOL. If you're able to do 5 and 6 EOL, that's fine, but just get started on the tangent. And then sine and cosine are on page 372. I want you to do 1 EOL, and then for question 6, do ACGL. If you're able to do 7 that you haven't been working too long, try and do 7 as well. But again, we're going to start doing the word problems in class.